now you guys take a break. Because I know you guys 너무너무 어려운 거 알고 힘든 것도 알아. Okay, so let's continue. Okay, we're still in the table one. I showed you how to do a sample one of the breakdown of how to do note taking outline 하는 거 방식 하나만 가르쳐줬어 아까. Okay, 나 이제 진짜 하나 큰 거 해보자. 같이. Okay, 지긋지긋하지만 이거 똑같아. 제일 중요한 거는 이거 지금 하는 게 아니었어. 왜 그러냐면은 항상 question 자체가 inference, factual, negative factual, ref 뭐 그런 거 다 나왔을 때 넌 노트가 벌써 이미 돼 있는 상태라고 노트를 부분하는 거라고. 네? 노트에 이미 돼 있으니까 이런 시간 낭비를 할 필요가 없는 거야. 만약 이것들 마지막 코스 진짜 한다 그러면 큰일이야 이거는. 왜냐면은 시간이 진짜 없을 거야. Okay, let's check it out. Okay, here we go. Okay?
Since the beginning of time, human beings have been fascinated by the dramas unfolding in the firmament above the shifting arch of the sun, the changing faces of the moon, their regular patterns of stars turning as the seasons change. The study of these subtle patterns and relationships in the cosmos evolved into astronomy, or law of the stars, one of the oldest of the sciences. While different cultures, religions, and scientific theories all offer contrasting explanations for cosmic phenomena, there is one point on which they all agree: there would be no life on Earth if not for the sun.
Okay, now if you take a look at this whole thing, 중요한 포인트 이렇게 있을까? 한번 봐. Okay? 한국 영어 자체가 너무 쓸데없는 진짜 많이 해. Okay? 그럼 봐. Since the beginning of time. Okay, we don't care. Okay? Humans, beings have been fascinated by drama of what? 이거는 general, so general. There's no point. Okay? Point 하나만 face of the moon, the pattern of star. We don't really care. It means in the past we were always curious about the star. Okay? Evolved into astronomy. So my main point, first one is what? Astronomy. Probably. Okay? And if you take a look at it, right? Astronomy. If you take a look at astronomy, then you're going to look down. You're going to continue reading. Science theory, all that explains what the astronomy is, right? 그 다음에 되게 중요한 게 뭐야? Last sentence. There will be no life on Earth, right? But what are they talking about? Life equals sun. Okay, so right away, the introduction for this paragraph here is the sun. So, look, you look over here on the right-hand side, and you take a look at my notes, right? The key points, really, at the very beginning, is so general. Then they go to the main point. Okay? And it is life equals sun. Okay? Let's go to the next one. Ken?
Modern science has now proven that the sun, whose reliable path across the sky gives us the contours of our days and the duration of our nights, is the focal point of our solar system. The sun is, in fact, a star that is nearly 110 times the size of Earth and comprises more than 99% of the solar system's mass, which creates enough gravitational pull to extend to the outreaches of our solar system and keep all manner of matter, planets, asteroids, meteors and even dust in orbit. Like other stars, the sun is made up of various gases, the most prevalent being hydrogen at around 74% and helium at around 25%. Because the sun's gravitational force inward is equal to that of its thermal pressure outward, it is in a state of hydrostatic equilibrium, which causes the sun to compress into a sphere.
Okay, now if you take a look at it, 여기 딱 보면은 벌써 번호들이 많지? 정식적으로 지워버리기 시작해, 머릿속으로. Okay? So let's break it down. Modern science has grown to provide that the sun, okay, whose reliable path across the sky gives us contour of our days and night. So basically, sun equals day and night. Boom. Okay, 썼지? Right? What's 보이지? Right? There's is the focus point of solar system. Okay, so you keep saying focus point of solar system 아니면은 center of us or center of system. Okay? Generalize 써도 돼. Okay? This says the sun is in fact a star. It's nearly 100. We don't care. Okay? So all we know is the sun is a star. We don't care about 110 times the sun Earth, 99% of mass. Just skip it all the way through. right? Which causes enough gravitational pull to extend. Okay, so that's the most point is what? Gravitational pull. In and out. Okay? Then it says planet as those are examples. We don't care about example. Like a star, we don't care. That's another example. Hydrogen and molecule, we don't care about the percentage. Helium, we don't care about the percentage. We don't care. These are 이게 모두 다 뭐야? minor detail. 쓸데없는 포인트들이야. 자사의 디테일이야. 자세한 거 다 필요 없다는 거야. Okay? Okay? Now equals outward, and then it says what? Hydrostatic equilibrium. You're like, what the hell is hydrostatic equilibrium? Okay? That hydrostatic equilibrium means if you don't know, right? Forget hydrostatic. All you have to know is equilibrium. You don't know equilibrium? Look at the first one. Equal. That's what it means. Equal. Okay? Equal to what? Sphere. That's it. Okay? 다음 거 보자. Okay, ready? Ken?
While the sun is a near-perfect sphere and appears to the naked eye as a precise and sharply defined yellow circle against the sky, hence its ancient astronomical symbol of a circle with a point at its center, the sun does not actually have a definite edge or boundary. Instead, the density of its gases decreases exponentially with distance from the core. Like most stars, the sun generates heat and energy via nuclear fusion, which takes place in the core at center of the sun. This energy must travel through a number of different layers before it reaches the photosphere, the first layer of the sun's atmosphere, where it escapes into space as sunlight. It is the photosphere that we see when we look at the sun. The layer is about 100 kilometers thick, which is relatively thin compared to other solar layers, and is much cooler than the sun's outermost atmospheric layer called the corona. One of the sun's great mysteries is the incredible heat of the corona. Usually heat decreases with distance from the core. This is true for the sun until you reach the corona, which becomes suddenly hotter by a factor of nearly 200 times that of the photosphere. The exact process of heating and maintaining the corona is still one of the unsolved solar mysteries that continue to fascinate and perplex scientists today.
Okay, now, if you actually take a look at this, right, then I know that this was pretty long, even for Kent to read all this, right? So basically, we're going to break it down. We're going to speed it up a little bit faster, okay? 더 빨리빨리 해야 되는 거는, okay? So we're going to go through each step, okay? First sentence, okay? Take a look over here, okay? While the sun is very near sphere, okay? So sun equals what? Perfect sphere, nearest perfect sphere, right? Okay? The second one is what? You're going to go to the naked eye, blah, 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 and hence the symbol of the center. The sun does not actually have a definite edge or boundary. No edge, no boundary. That's the point. Okay? Instead, the definite gases, okay, those like star, those are minor details, okay? The sun generates heat, energy, and nuclear fusion, okay? So energy, nuclear fusion, okay? Which takes up a place at the core of the sun. The sun energy must travel through a number of different layers. Okay, so we've got, okay, layers? What layers? Okay? Whoa. Okay, what layer? First one is what? Photosphere. Okay? The first layer of the sun's atmosphere. Okay, so we're going to say photosphere, first layer. Okay, what about the photosphere? More definition, what is it? It's what? Relatively thin. Great, thin. Okay, compared to solar layer, okay? And is much cooler than the outer layer, okay? Atmosphere layer called the corona. So the outer layer is what? Corona. Okay? Right away. Okay? Then he talks about corona. He decreases into blah 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 and through the sun until you reach the corona, which becomes suddenly hotter than the factor of 200 times. Those are some numbers. Okay, the exact process of heating and maintaining the corona is still one unsolved. So we don't know the mystery of heating and maintaining. Okay, that's your notes. It's pretty easy. We're breaking it down. Okay? Let's see. Let's have Ken read the next one.
Another solar mystery is the curious nature of solar flares, equivalent to millions of 100 megaton hydrogen bombs detonated simultaneously. Solar flares are the most intense and energetic explosions that occur in our solar system. These explosions occur on the sun's photosphere and are difficult to view through layers' bright emissions, even with specialized equipment. Solar flares are directly linked to another more easily observable solar phenomenon, sunspots. With the invention of the telescope in 1608, astronomers were finally able to look into the face of the sun and see that it is not a perfect and unchanging yellow disk as they had expected, but that it is often marred by discernible blemishes or dark spots. These dark areas are the coolest regions on the sun's photosphere and are characterized by intense magnetic activity. The frequency of sunspot occurrences follows an 11-year solar or sunspot cycle. At the minimum end of the cycle, there's very little sunspot activity, and at the maximum end, there might be hundreds of visible sunspots. An increased number of sunspots indicate a correlated increase in solar flare activity. This period of activity can pose a serious danger to satellites and astronauts. One solar flare can emit enough magnetic energy to cause serious damage to a satellite, or change the satellite's orbit. It can also shake the Earth's magnetic field and cause dangerous surges in power lines, resulting in blackouts over large areas. Because of these dangers and our increasing reliance on satellites, it has become even more important for scientists to understand the nature of solar weather and to determine more accurate methods of predicting solar activity.
Okay, now that's pretty long. Okay, now we're gonna all 잘 breakdown 시킬 거야. Okay, ready? 짧게 만들자. Over here. Okay, look. Another solar mystery. Another mystery is about solar flares. So what is the main idea? Everyone should automatically know solar flare. 제일 중요하잖아. Equivalent to, we don't care about what's equivalent to. That's like saying like. Like은 똑같은 거잖아. 필요 없어. Okay? That says what? Are the most intense and energetic explosion. So it's intense. It's a huge explosion. Okay? The explosion occur on the sun's photosphere and are difficult to view. Okay? So all you gotta say, you can't see it. Okay? Solar flares are directly linked to another easily observable solar phenomenon called sunspot. Okay? Linked to what? Sunspot. Okay? What is, they're like, okay, teacher, I don't know what sunspot is. Wait! That if you don't, 만약 sunspot이 뭔지 모르면은 probably 99.9% of the chance the reading is going to tell you what it is. With the invention of the telescope in 1608, 날짜가 필요 없고, astronomers or scientists were finally able to look up the face of the sun and see that it is not a perfect or unchanging yellow disk as they expected. So they found that it's not what? It's not a circle. What is it? It's a blemish or dark spot. It is the sunspot. Okay? Okay? Why is it dark? The darkest area is the coolest region. It's a cold area. Okay? Then what does it tell you? The frequency of the sunspot occur fluid is of 7 years. We don't care about dates. Cycles, we don't care. Maximum, minimum, we don't care. Hundreds of square, we don't care. These are all minor details. We're going to skip all the way through. The period of activity pose serious danger to satellite. We don't care. We're going to say what? We don't care about satellites. Those are examples. The solar flare, okay, can emit a magnetic activity, energy. The magnetic activity is the one you're going to put in. It can cause you, there's a minor detail of what damage it can cause to humans, okay? The results back out, all these are basically minor details of what happens, okay? So it's very dangerous, okay? And these are what? Very important to scientists. Why? To understand the nature of solar weather, okay? And also predicting solaria, okay, activity. Now, we went through all of this. You guys should have all have this notes, okay? And the question looks like this. Okay, see the table? And the direction says what? Complete the table below and identify examples of the type of characteristics discussed in the passage. Match the example with the type of characteristics in each one. So if we're talking about solar layers and solar activity, okay? And then they give you the answer choices at the bottom like this, okay? Now, for our purposes, we're going to change it a little bit. We're going to do it my way so you can see it better. So, boom. So, we actually did it my way so you can see the letters a lot better. The other one, you can't really see it, right? 잘 보이지도 않잖아, 이거는. Okay? But, 되게 중요한 건 여기야. Okay? We're gonna extract solar layers and solar activity. 이거 두 개를 다 분해시키는 거야. Okay? So let's take a look. Okay? Look at the. We're gonna take your notes. We're gonna bring it up. Ready? Here you go. 너 노트 다 보이지 위에? Okay? And then now we're gonna put the solar layer 여기 놓고 solar activity 놓을 거야. And then we're gonna look at each one. Okay, let's look. Okay, photosphere. Okay, find photosphere in your thing. Okay? I see it right in the middle. What is the photosphere? Right above the photosphere, what does it say? Layers. Right? Right? 딱 가운데 보이잖아. You see photosphere, you see layers. So that means photosphere is a major detail for layers. So what is it? It goes under solar layers. Right away. 하나 벌써 맞았어. Okay, let's see. Hydrostatic equilibrium. Let's find hydrostatic equilibrium. 찾았다. 저쪽에 있지. 너 노트에. 왼쪽에. Right underneath gravitational force, in force downwards, hydrostatic equilibrium. Is it in any solar layer or solar activity? No. Okay? 안 들어갔잖아, 이게. Okay? So let's just put this down for a while. Okay? Okay, solar wind 찾아봐. Do you see solar winds? Do I see solar winds in your notes? Do you find any? No, 없어. Let's hold that off for a little bit, okay? Okay. Corona, okay? So where do you find corona? Right in the middle, right? It says what? Thin layer. Where? Layer. Thin layer of what? Right above the photosphere is what? Layer. So where do you think the corona goes? In the layer section, right? Okay, now check this out. Sunspot. Can you find sunspot? I can. It says linked sunspot. But what is a linked sunspot over here referring to? Up there? Solar mystery equals what? Solar flare. Right? So it's a solar activity, isn't it? You put it up there. How about solar flares? Where do you find solar flares? Do you see solar flares? Right there. That's the same thing. It's solar, right? So it's solar activity, solar mystery, and magnetic emission is under what? Right underneath here it says coolest region, magnetic activity. Where does it go? In the same solar flares. Solar activities, right? So, believe it or not, your notes has all the answers for all these categorization. 여기 answer 다 들어가 있어, 여기 안에. 그러니까 reading and note taking 안 한 사람들은 대부분 factual, negative factual. 나 13th question 4점짜리 거, 3점짜리 거, 2점짜리 거 다 틀려. Okay? And you scratch your head. 왜 틀렸지? Right? 점수 만점 못 받아. 절대로. Okay? So the answers, we go back to solar flare is photosphere, corona. Sunspot, solar flare, magnetic emission. And this is the perfect answer. Okay? And this is how I want you guys to do reading. Okay?